Welcome to another video example looking at a hypothesis test that we're going to conduct using a randomization distribution. We have an experiment that was conducted to compare the maximum speed at which people can tap their fingers between people who drink caffeine and people who do not drink caffeine. 20 subjects were randomly assigned either to drink a beverage with caffeine or to ingest a similar non-caffeinated beverage. The maximum tap speed of their fingers in taps per minute was recorded for each subject. These data are available in StatKey, so I don't have them here, and we're not going to have to type them in. But we want to know, do the data provide strong evidence that the tap rate is higher in people who drink the caffeinated beverage compared to people who drink the non-caffeinated beverage? Okay, so let's start by setting up our hypotheses. We want to know, do these data provide strong evidence that the tap rate is higher in people who drink the caffeinated beverage compared to people who drink the non-caffeinated beverage? That's going to be our alternative hypothesis. We're going to want to write this in terms of parameters. Now, it doesn't mention a mean or a proportion here, but we know that tap rate is our variable, and tap rate is quantitative. So when we summarize a quantitative variable like tap rate, we summarize it with the mean. So here we're going to be comparing the means in the two groups. So let's call mu sub 1 the tap rate, the mean tap rate, for all people if given the caffeinated beverage. And we'll have mu 2 be the mean tap rate for all people if given the non-caffeinated drink. Then our alternative hypothesis is that the tap rate is higher for the people given caffeine. So mu 1 is greater than mu 2. And our null hypothesis is that the two mean tap rates are the same. We need to choose a significance level for our test. Let's use a significance level of alpha equals 0.05, 5%. And now we're going to go to StatKey to take a look at the data. Okay, so in StatKey, we need to do a randomization hypothesis test, so we're working in this area. We're looking for a difference in means, so we're going to click on that. And here we are. Now the data that is loaded in here right now is leniency and smiles. We need to go and find the finger taps on caffeine. There we go. So we've got the caffeine has an average rate of 248.3, the no caffeine 244.8. We've got our sample sizes of 10 each, and our sample estimate for the difference is 3.5 taps. Okay. Our null hypothesis is always set up to be that the means are equal in this situation, so we don't need to change anything there. And we need to generate our 5,000 samples. So we generate 1,000, 2,000, 3,000, 4,000, 5,000 samples. Now, let's look at our alternative hypothesis. Our alternative hypothesis is that mu 1 is greater than mu 2. Greater than sign means I'm doing a right-tailed test. So coming back in here, I'm going to do right tail. Now, here I've got 0.025 is the proportion of the dots that are up above 2.5, but that's not my observed difference. My observed difference is 3.5, so I need to change this cutoff to 3.5. I click OK. And now it tells me that the proportion of dots that are up here that are as extreme as 3.5 or more extreme is 0.0022. So that is my p-value. My p-value equals 0.0022. To make a decision, I compare this to my significance level. This is less than my significance level. So I reject my null hypothesis. Which means that I have strong evidence in favor of the alternative. There is strong evidence that the maximum cap rate on average is higher in people who drink caffeine than in people drinking a similar non-caffeinated beverage. Furthermore, because I have an experiment here in which the people were randomly assigned to the two treatment groups, I can actually say that this difference was caused by the caffeine. So that caffeine actually increases the maximum tap rate on average compared to drinking a similar non-caffeinated beverage. Thanks.